So for this one, I'm going to be showing you all how I built this AI-powered chess app. It's using OpenAI's API on the backend. Backend's written in Go, frontend's written in React and TypeScript and ChatCN and Tailwind and all that stuff. Yeah, so I'm going to just show you all how I built this. I'll treat it as a tutorial if you want, but without further ado, let's head into the code. So I actually went ahead and created a directory called ChessGPT app. And in here, I'm going to create a server, a folder. So we'll say McDirt server. I am also going to go ahead and install, geez, I cannot type and talk at the same time. pn create vite, a template, react, ts. I'm forgetting what this is off the top of my head. Yeah, and we'll name it client. So, all right. So now we have our client on our server, and we can go ahead and open this in VS Code. From here, I'm going to hit Control-J, open the terminal. Inside of the terminal, we'll do cd server, and we'll do go mod init. This is going to create a new Go project, and we'll call it chess API. Right, so this is going to be our actual backend. So there you go. This is like the equivalent of a package JSON for a node-based application. So right now what we're going to do, actually, first thing I want to do is create two files. So we'll say main.go, and this is going to be like where all the server code goes, and we'll say .env. .env is where I'm going to be putting my environment variables, like my OpenAI API key, which I will not be showing y'all because that's none of your business. But if you pay for one, then you can basically do what I'm about to do and fill in the blanks. So in here, I'm just going to paste those. Here, I'm going to actually put my OpenAPI key. My terrible naming conventions. My OpenAI API key is going to go over here. And this is going to be the port that our server is going to run on. And I have this debug variable that I'm going to be using to basically log out all the requests and the responses. So once you have your environment variable set up, first thing I want to do is add some Go packages. So we're going to run go get. I'm going to be using Gin. That's a web framework for Go. Just lets us write more with less. I'm also going to add the cores package for Gin. I'm going to add go.env. Let me hide my sidebar. This is going to let us load our environment variables from the .env file. I'm going to be adding this is hard to read. Let me zoom out. There we go. I'm going to be adding the Corintings chess package. So this is just to do like validations to make sure that we're passing legal moves along to OpenAI. Because I find that without doing this, sometimes OpenAI will actually hallucinate a lot of moves that it can't actually do. So let me go ahead and add those first, and then I'll add the next couple. So the last thing we're going to want to add is the OpenAI Go package. All right, so go ahead and hide this for now. And then in main.go, first thing, we're going to declare our main package. I'm going to be putting everything in the main.go file because I don't feel like splitting everything up right now. Then I'm going to import the log standard package as well as Gin. Next, we'll define the main function. We'll initialize a new Gin router. We'll pass in some logging middleware. And then we'll pass in the recovery middleware, which is for handling internal server errors. And then we can actually run our server. Open up the terminal, go run main.go to actually run our server. And there you go. Server's running on localhost 8080. I'll next add a simple health check-in endpoint. It'll accept the Gin context, and it'll respond with a string, ChessGPT server's running, as well as the code 200, which means everything is going okay. To use this handler, right underneath where I define my router, I'll just say r.get/health, handle health, and this will pass our route handler to this /health endpoint. So we can hit save, run our server again, allow, and then if you actually open up 8080/health, you'll see it says ChessGPT server is running, and you can see that it actually accepted a request. We can do that again, and there you go. All right, so next let's add some environment variables. Down here, we'll add the OS package, and then we'll add the go.env package in our main function. We're first going to load our environment variables, and this is going to be the error if we don't have any environment variables, or sorry, an environment variable file. Once that's done, we can actually define our port based on the port value inside of the .env file. Then we can replace the hard-coded 8080 value with the port value from our environment variables. And we can also update this line over here so that we're using the same port value. We can hit save, cancel, run again. And of course, we just want to verify that this is actually working. Looks like it's working. Cancel out of that. And now we can add some core support. So right up above where we're importing Gin, we'll import the cores package for Gin. And then down right underneath where we initialize our router. So I'll actually say init router. We'll say configure, I will just say course. And then we'll actually pass in course config. Now, I do want to note this right here. Don't do this in production. This is just saying everybody can access this API, and you don't want everybody to access your API. Otherwise, you'll be paying a lot of money to Sam Altman. So this is just for me because I made this for like as a prototype and as a test. But just keep this in mind. So say to do, don't do this in a real client and not the entire universe. All right. So down here, I'll just say routes, and I'm going to pass in an options route. And what this is going to do is this is going to be a pre-flight check for the client when they want to make a post request. So this just tells them whether or not they're allowed to do a post request. And of course, we're just going to send back 200. So now we can get onto the fun stuff. We can start adding OpenAI support. So we're going to want to add a few packages right up above our login OS. We're going to add the context and FMT standard packages, as well as the strings package for string manipulation and the time package so that we can handle timestamps. And right under go.env, we'll add our imports from the OpenAI Go package. So back in main, I do want to, we'll say load.env, and then down here we'll say read.env, and right above the port, we will add our API key. So get the API key. If none, then scream at them. Assuming that works, right above our router, we'll just say OpenAI. Is that how they even spell it? Or is it like that? I think it's like that. OpenAI client. All right. So this is going to pass our API key from our environment variables to OpenAI. And of course, because it's not going to allow us to define a variable and not use it, we'll just say underscore equals client just as a placeholder. So next, I want to create a method that we will use to prompt OpenAI or OpenAI's API. Or yeah, it's going to be a method that passes along the prompt, calls OpenAI's API, gets the response, does stuff with it. So this function is going to be called getAIMove. So the function getAIMove is going to accept the following parameters. So it's going to accept an OpenAI client, the fen value, which is basically a representation of the chessboard currently, the current move history, the moves that the AI is allowed to do, as well as the difficulty setting that the user has chose, or that the user has chose is correct. Close that, and this is going to return a string value and an error. I'm just going to close that function real quick. First, we'll do a quick validation. If no difficulty is defined, then we'll just immediately set the difficulty to intermediate. We'll then define our system prompt. So this is going to be the prompt that actually informs the model how to behave. So I just need to import FMT, which I thought I did earlier, but maybe when I saved and I didn't use it, it removed it. So then next we'll add our user prompt. So the difference between the system prompt, right, is this informs the model how it's going to behave, or the system how it's going to behave, right? So it tells it you're going to receive the current board position, the move history, a complete list of moves. The response is exactly one move in SAN, so that's the standard algebraic notation, and it must be one of the legal moves that are provided. And don't yap at me, right? So then the user prompt is the actual like information, right? So this is the current position, the move history, legal moves, right? So it always needs both a system prompt and a user prompt. I could have swore we installed strings, but let me try that again. Oh no, wrong one. All right, there we go. So next we will define our context and a deferred cancel, or make sure to import it, which I thought we did. And basically what this is for is to just time out the call if the model just takes too long to respond, because we don't want to be sitting there waiting for half an hour to get a response for a single chess move. And then we'll defer the cancel call. If the 10 seconds have passed, then it'll cancel. So next, we're actually going to define the chat completion. And this is going to be think of this like the method that actually defines like the entire interaction with OpenAI or the OpenAI model. So, whoops. In here, it's going to accept a model. So in our case, we're using a model 4.0, just because I think this is a reasoning model, so it's a little bit smarter. But if you want to save money, you can use like 3.5 turbo. I found that like, I don't know, maybe like 100 chess games cost me like $2. So we're going to pass in our system message and our user message. So our system prompt and our user prompt. We'll define our model's creativity value. Yeah, so the lower this is, the more like robotic and computer-like it is. The higher it is, up to 2, the more like, quote unquote natural it's going to behave. And then we don't want any more than 5 tokens in response, because all we're going to need is just like a response for the move, which is going to be, I think, 5 characters is like the max. So we'll close this. We'll handle the OpenAI error. if any exists. And then if it does not respond, we'll also handle that. And assuming that it didn't have any errors and it actually did respond, then we'll be able to extrapolate the move from the content that it sent back to us. So remember how we had defined our legal moves earlier? Well, what we can do now is we can actually iterate over that slice, and we can figure out if the move is part of those legal moves, which we'll get from the chess package in a second. So assuming that it actually found the move in the slice of legal moves, and a slice in this case is kind of like an array, if you're not familiar with the Go terminology. So assuming that it didn't find it, then we actually have to handle this error, which we can do like so. So go ahead and save that. And now we have the function that we'll actually be able to use in our handler. Before we can define our handler, let's head to the top. We'll say right underneath our imports, we'll define the struct for the request for a move from the AI. So this will accept the FEN, the history, the move history, as well as the difficulty setting. And it'll respond with either a move or an error. Well, actually, in this case, it'll respond with a move and or an error, right? Because error can be empty. Next, we want to actually validate the FEN that we receive from the client, as well as the and get the legal moves that we can actually use, which we'll pass on to the AI. So this will accept the FEN as a string, and it'll return a slice of strings and an error. We do want to make sure we import the chess package. So what we're going to want to do first is define a chess game based on the FEN string that we are receiving from the client. So this will act both as a way of validating that string and computing the possible moves for the current state of the board. We'll set our notation to SAN, or standard algebraic notation. We'll define the legal moves that we can make. And then, because I believe they come out as default as UCI, we will iterate over that slice and make sure that they are defined using SAN notation, and we'll return that slice and no errors if we arrived to this point. So now we can save, and then right underneath getAIMove, we can actually define our handleMove handler function. So this is going to be the logic that actually gets called when the /API/move endpoint is called from the client. Just make sure we close that. And this is going to return a function that takes in a gen context. We'll first validate the request body. We'll log the contents of the request, and then we'll validate the FEN value and get the legal moves that we can then pass on to the getAIMoves function. Make sure to log it and get the AI moves from, well, getAIMove. So this is going to be the part that actually calls the OpenAI method, the OpenAI API, and if successful, receives the move that we can send back to the client. So now we can log the move that we're going to send back and actually send it back. Now, last thing we need to do is head down to our routes, and right above the options, we can say r.post /API-move handleMove. Save that. So now let's wrap up by organizing our code. Right underneath our move response, we want to define a chess server struct, which is going to just accept the client, the OpenAI client, and we'll define a function called new chess server, which will accept the API key and will return a instance of the chess server. And now we can actually annotate the function with a chess server receiver, which means that instead of having to accept a client, so instead of this being a pure function, this will act more similar to what you would expect from something like a little bit more object-oriented. So in this case, this will accept a context. So we'll just say parent context, and here we'll say context.context. That means down here in our context, instead of passing the context background, we can say parent context, and instead of using client, we can use the S that represents the instance of the client, of the chess server, then the client of that chess server. And that means we can also define our handleMove function as a receiver of the chess server, like so. So we can get rid of that function declaration inside and just accept the gen context directly. Just make sure to remove the extra brace at the end. And then down in our main function, where we're defining client like this, we can instead just initialize a server instance by passing in the API key and using our new chess server function. And then down in the handleMove router, instead of passing down a pure function like this, we can just use the server instance that we just created and call its new handleMove method directly, because this is now a receiver function of the server type. Of course, back inside of the handleMove method, I do need to modify getAIMove so that it uses the server instances. Because this is now a function of the server instance, we'll define it like this. And we no longer need to pass the client. We can just pass the context. So we'll say c.request.context, like so. And now we can hit save. And now down inside of our main function, right above where we define our server, I do want to also have the optional debugging step. So we'll just say optional debugger. And this will just let us, or debug logs to files. And this will just let me actually like see all of the sessions in a log directory. So go ahead and pause and copy that if you want. But this will just require the imports for the file path package as well as the IO package. And if you recall that environment variable debug that we defined earlier, this is what allows us to write out those logs to those individual files. So go ahead and hit save. And now we can go ahead and run go run main.go. And hopefully this works the first time. There we go, we allow. And I am gonna use the old UI that I already created just to verify that this is actually working. This isn't really useful for you because, well, you don't have access to that yet. But do not worry, we will get you there soon. So we'll just refresh. This is stored in local storage if you're wondering why the game is still present. So I am gonna create a new game. I'll play as a black and we'll do beginner this time. So there we go. The turn was played. Let's go back to our VS Code. And I'm just going to, you see there's the new logs folder, and you'll see that, there we go. The actual moves are being logged, and I don't know why. Well, I guess I do know why. The optimal starting position is always E4 for some reason. So it always uses E4 when it starts when it starts the game, right? So you'll see there's the FEN request that came from the client, as well as the beginner difficulty. No history because I let it play first. So there's the legal moves calculated from the chess package that takes the FEN value and gets those. And then this is the response from OpenAI. So yeah, that's it for the API. Now we can go ahead and jump into the UI.